The main premise of this task is to get you to recognize that, and I've already mentioned it before, the nth root of something is the same as a to the 1 over n power. So for instance, if you look at this 4 to the 1/2 power, you can use a calculator. A calculator will give you the correct answer. Otherwise, you can say it's the square root of 4. And by the way, if you ever have just a square root, you don't need a 2 right here. So this first answer is 2. Yeah, let's put a box around that. So as a reminder, this next one, and again, you can use a calculator, this is the same thing as the cube root of 64, which if you broke it down as 4 and 16, and then 4 and 4, I think it's pretty obvious that the cube root of 64 is 4. Otherwise, you are free to use a calculator. Moving on to the next one, there's really nothing that you can simplify it to. They just want you to rewrite it as the 4th root of x. I meant to change colors, but that didn't happen. Now this next one, pretty straightforward. It's the 6th root of 0, but any root of 0 is going to be 0. So that's what they mean by simplify if possible. Okay, this next one might confuse a few people, so stick with me. Because your order of operations matter, so this is the same thing as doing the exponent first, so it's the square root of 9, and then the negative of it. Just think about your order of operations. You do your parentheses first, well there's no parentheses, then exponents, and then this is technically a subtraction problem. Heck, you could even put a 0 in front if you wanted to. 0 minus 9 to the 1/2. Either way you go about this, this answer is -3. So how would that be different is if we had -3 to the 1/2 power. Whoops, I meant to say -9. This is no solution because you cannot square root a negative number. So there's a big difference here. So pay close attention to that. Moving on to the next one. You just have to make sure that you do the 4th, because of the parentheses, you have to do the 4th root of each piece. 81 x to the 8th. So the 4th root of 81, again, you can use a calculator. There's nothing wrong with that, is 3. 4 3s get you to 81. And then you've also heard me talk about dividing. 8 divided by 4 would give you that 2. Another way you can think about this, and we did this a long time ago, probably in the first semester, is you can take this 1/4 power to each one of these. So don't forget that you would multiply your exponents. 8 times 1/4 is 2. So that confirms that answer. And then this last one, again, the order of operations matter. There's no parentheses, so it's 5 times the cube root of y. But there's nothing to simplify there. So that is all you can do. So what we did next is we threw in an extra variable. But notice in the previous problem that it was all to the 1 over, 1 over, 1 over. So this rule still applies if it was 1 over. It's just basically saying it's 16 to that power. Now there's 2 ways you can solve it, because you can think of it as the square root of 16 cubed, or you can think of it as the square root of 16 cubed. Now, I can't do this problem in my head because I don't know what 16 times 16 times 16 is. So I don't typically do the problem that way. I typically do the square root first and then cube that number. So the square root of 16 is 4. Cubed gives me an answer of 64. That's how I do this in my head. You are welcome to use a calculator though. Just as a heads up, notice that the numerator is the power and the denominator of that exponent is the root. So as I move on to the next one, it's the negative of the 5th root, the denominator, of 1 cubed. Now this one I could do either way because the 5th root of 1 is still 1. 1 to any power is still 1. Could have said that up here. And then the negative. Notice the order of operations are still applying here. So again, I have a way of doing this. I would prefer to do the 4th root of 81 first and then cube the number, and then the negative goes in front. So we just did the fourth root of 81 a second ago was 3. 3 cubed, that means 3 times 3 times 3 is 27, and then don't forget about that negative. By the way, you can do this individually for each base. So as I look at the next one, it's the same thing as doing 1 to the 3 halves over 25 to the 3 halves. Taking it to each base. Now I already mentioned 1 to any power is 1, so that one's pretty easy. But what this actually means is the square root of 25 cubed. Well, the square root of 25 is 5, cubed is 125. So this final answer is 1 over 125. Now there's not much to do in this last one. It's just more or less, just write it out, is that you understand it's the 9th root of the quantity of 3x plus 2 to the 5th power. And there's really nothing else you can do. I'm not expecting you to be able to take a binomial to the 5th power yet. That's a future Math 098 problem. It might even be like the next class. So one more rule. These are all rules in your book, by the way. I'm not just making these up. Is you may have forgotten, so here I am reminding you, that a negative exponent sticks the problem into the denominator, moves to makes it positive. So if you're doing this step by step, this first one is equal to 1 over 16 to the 3/4 power. But that's where we get back into rewriting the 3/4 power as the 4th root of 16 cubed. And then you can methodically work through it. The 4th root of 16 is 2. Go ahead and move it down. And you can use a calculator. And 2 cubed, that's 2 times 2 times 2, is 8. So 1/8 is your final answer. Notice that the negative matters here. You see the negative is part of the power. So just to work this out step by step, it's 1 over, it's still a negative 27 because of this negative, but this negative, because it's in the denominator now, becomes positive. So now what I would do is figure out the cube root of negative 27. We're going to square it. Well, the cube root of negative 27 will give me negative 3. Notice that it's still in parentheses, because now when you square negative 3, you get a positive 9. And hopefully that made sense. You can rewatch the video, you can go back, make sure you understand as I move forward. So we're going to work through the properties of exponents. It may have been a while, and notice that my division signs don't always show up, so I got to make sure that they show up for you. So a while ago we practiced that when we multiply with the same base, we add our exponents. So this is the same as y to the 2/3 plus 8/3. It's been a while since we've done that. So this is equal to y to the 10/3 power. And based off these directions, it just says writing with only positive exponents. I would say that this is a good enough answer. But in case the book or back of the book wants something else, you could rewrite it as the cube root of y to the 10th. So I'll accept either of those answers. I really did not give myself much room here, so hopefully you can follow along. The issue, though, is that only works if your denominators are the same. What happens if your denominators are different? Now, we are still going to add 3/5 plus 1/4, but what we need to do is change the denominators to be over 20. That way, we can combine those terms together. So 3/5 as a denominator of 20 is 12 over 20. I hope you agree 12 over 20 reduces at 3/5. And then plus from right here, 1/4 with the denominator of 20 is 5/20. So now we can actually add those together, and we're looking at x to the 17/20. And again, if you wanted to, you could rewrite this as the 20th root of x to the 17th power for that problem. And I really regret not giving you guys more space. But if you're writing on notebook paper, then you should be fine. This one, remember that you subtract your exponents. So when you're dividing with the same base, you subtract. So 2 minus 9 is negative 7/7, which is the same thing as 9 to the negative 1st power, which is the same thing as 1/9. And then one more example. This is kind of nice. They have the same denominator already. 4/9 plus -2/9 gives me b to the 4 plus -2 is 2/9. And this is acceptable, but just to give you practice one more time, it's the 9th root of b squared. As I move on to the last exercise here on exercise 4, example 4, is reminding you that you can only have positive exponents and your bases cannot repeat. So we have quite a bit of work to do. So the first thing I would do is make sure that I take to the 4th power to all of these. And remember, a power to a power you multiply. Let me squeeze this right here. So I'm looking at 3 to the 4th. And you have to multiply 1/4 times 4. Well, 1/4 times 4 is 1. And then -2/3 times 4, you just multiply into the numerator, so it's -8/3. All over x to the 4th y. But now my bases are repeating. So you might want to go through the process on, that's a 1 right there, by the way. Doesn't look like a 1 to me. And I would actually rewrite 3 to the 4th as 81. It's just a habit of mine. And so you subtract your exponents. 4 minus 1 is x to the 3rd. Y to the 1st in the denominator is larger than this. So I'm just thinking, well, how can I do 1 minus 8/3? Well, maybe I would change 1, do a different color, to 3/3. I hope you agree that 1 is equal to 3/3 minus -8/3. Well, subtracting a negative turns into a plus. 3 plus 8 is 11/3. Because the denominator stays the same. So this is an acceptable answer. But again, if the back of the book has a slightly different answer, it might look like this. X to the 3rd, and then the cube root of y to the 11th. So don't be afraid if your answer is different than the back of the book. Just looking ahead, I don't think I can finish these notes on this video, so I'm going to stop it here and see you in the second video.